So if we have a function that is defined using two or more, sometimes more, usually we just do two though for the sake of simplicity, pieces, equations over a specified domain, we have what's called a piecewise function, or a piecewise defined function if you want to be a little bit more picky about the wording there, where this is a function that has some abrupt changes in its behavior. It suddenly may jump to a completely different kind of function at a specific value. We can still look at it in terms of things like being even, odd, increasing, decreasing. It's just we have to be a lot more careful about how we define those things. We have to be very careful about how those values might fit into the pieces of the function as it goes, and it's a little bit more work, where you might think to yourself, a piecewise defined function just sounds like it'd be very inconvenient and not very useful, but actually one very simple real-world example that all of you will either have or are going to have experience dealing with is the way that progressive tax brackets work. That is, because in a progressive taxation system, the amount of money you have that fits into each bracket is taxed at that bracket's percentage, the total that you're paying will change depending on how high you get into each bracket and what brackets you're in. It's very different behaviors based on how far along in the system you are, so that would fit a piecewise definition. It's a little bit more involved than what we look at in this class, even for the American system, which has quite a few variations on it. So we'll start with a bit of a, let's say, smaller example. Weird. So for this example, we want to graph the piecewise defined function 3 for x less than or equal to 1 and x minus 2 for x strictly larger than 1. And to do this, to do anything we want in terms of defining and describing the behavior of a piecewise defined function, we need to start by thinking about what happens on each section. So for the stuff that is less than or equal to -1, we're going to get some points like -1, -2, and -3, and see that our function f here is just 3 at all those points. It's not very interesting. So we get the points -1, 3, -2, 3, -3, 3, 4. To keep going, we get -4, 5, 6, 7, 8, 9, 10, and so on, all giving us 3. It's not very exciting, but it is very nice to be sure of ourselves. Meanwhile, on the other side, if we take values like -1, we would get -1 minus 2 is -3, so at the point -1, -3, we'd have the point -2 at 0 for hopefully obvious reasons, so 0, -2, and then at 1, we would get 1 minus 2 or -1, so we'd have the point 1, -1, and thus on one side we have that nice constant thing, on the other side we have a nice diagonal thing. Overall, we'll end up with a picture that looks a bit like this. And the last thing we're going to see from this section is a little bit of a change. It doesn't quite fit with the other constructions we talked about, but it is a very specific, important thing that we're going to be looking at to finish up here. We're going to be spending some time with what are called difference quotients.